Searching for targets in satellite imagery is a difficult and time-consuming task for the image analyst. The presence of clouds, land, and rough seas make the manual search even more tedious. Today's image analyst needs a powerful, user-friendly tool that can automatically detect targets from satellite imagery. Heidi Buck and a team of developers at SSC Pacific have created such a tool, RAPIER, the Rapid Image Exploitation Resource.
RAPIER is a framework for processing satellite imagery, both commercial satellite imagery and national satellite imagery. It's a tool for the image analyst to look for targets of interest or analyze their imagery, and it's also a tool for the image scientist to develop new sorts of image processing algorithms to plug into RAPIER. You could develop algorithms for target detection such as airplanes, vehicles, people on the ground, roads, anything you can think of really. We've developed the RAPIER ship detection system, which is just one plugin to the RAPIER framework. The RAPIER ship detection system takes a satellite image of a port or an open ocean area, and it's looking for ships or objects on the ocean surface to detect those objects and report those objects out in a fashion that the analyst wants to see.
With the press of a button, the RAPIER ship detection system automatically processes an image using a suite of algorithms. These algorithms work in the background to detect and classify ships.
One of the first things RAPIER does is perform a land masking algorithm. In this algorithm, we distinguish the difference between land and water in the image. We therefore mask out the land and process the water, searching for ships.
Two of the most common sources of false alarms in the ship detection area are clouds and noise due to high sea state. And we've developed algorithms to deal with both of these problems. Let's say you have a very noisy sea state or background and you have a very small ship. The problem might be, how do you detect the small ship without getting lots of false attacks on this very noisy ocean background? We've gone and developed algorithms that characterize that background and then change our detection algorithms to find the small ship and not have lots of false attacks.
RAPIER is capable of detecting the presence of wakes in an image. If a wake is detected, we can use this information to determine the ship's heading. If no wake is present, we then proceed to analyze the bow and stern curvature. Once we distinguish the location of the bow, we can use this information to determine the ship's heading.
By analyzing the ship's characteristics such as length, width, and deck features, RAPIER can provide a possible ship type. Some of these deck features we look at are domes, containers, and hatches.
RAPIER compares the features from the detected ship to a rule set that we created. The rule set was developed based on analysis of a database of over 500,000 ships. Once the information is compared, RAPIER outputs the most probable ship type.
After processing is complete, the results of all the algorithms are output into formats that are easily interpreted by the end user. The first output is an HTML tip sheet, which includes the probable ship type with the confidence rating, length and width, latitude and longitude, and heading for each detected ship. The tip sheet is organized by ship size, which makes it easier for the end user to browse through the results. Another format is the shapefile, which is used as an overlay onto the original image, allowing the end user to highlight detected ships. And a KMZ file, which links each detected ship with its geographical location for viewing in Google Earth. RAPIER also produces several text-based output files.
So the idea of being able to automatically process these images and quickly look at these results is a much simpler solution for the analyst than manually going through the image and dealing with weather and sea state and lots of targets to look at. Applications for the RAPIER ship detection system include port, coastal, and open ocean surveillance, monitoring of fishing zones, assistance for search and rescue, drug and human trafficking monitoring, and merchant vessel tracking. The RAPIER framework is designed to handle a variety of different data sources. Specifically for the ship detection system, we're looking at EO imagery and SAR imagery, but it can handle a variety of others, multispectral, IR, and we're processing images up to 4 gigabytes in size, so it's really powerful in that respect. So the RAPIER ship detection system really demonstrates the power of how many tools there are already available in RAPIER, such that the image scientists can come along, they can develop any sort of algorithm of interest for any target of interest, and they'll have a very powerful suite of tools at their fingertips. Future plugins that we plan on incorporating would be something like fire detection algorithms for multispectral imagery, or also vegetation index analysis algorithms to look at where the soil is dry and wet for landing sites. Also oil slick detection for SAR imagery, iceberg mapping and tracking. A variety of different things that aren't just related to the maritime domain and oceans and ports, but also plugins for overland and target detection and analysis overland as well.
The Rapier framework and the Rapier ship detection system are powerful new tools designed to revolutionize satellite imagery analysis. How can Rapier work for you?
SPAWAR System Center Pacific is a U.S. Navy research and development lab located in San Diego, California. The center is supported by a workforce of 2,000 scientists and engineers who are developing the latest cutting-edge technologies. We are looking for strategic partners to help us commercialize our technologies for DoD and civilian applications. For more information on this technology or any of our technologies, please contact us or visit our website at spawartechtransfer.navy.mil.